theory. What is molecular orbital theory? Number of atomic orbitals overlap to formation of molecular orbital. Okay, so here for example, two hydrogen atoms, their atomic orbitals, for suppose 1s and 1s, undergoing to overlap to formation of, this is 1s molecular orbital. Molecular orbital, a simple one. Number of atomic orbitals undergoing to overlap to formation of molecular orbital. Okay, what are the conditions for MOT? What are the conditions for MOT? Number of atomic orbitals combined equal to number of molecular orbitals formation. So here number of AO means atomic orbitals combined or overlap equal to number of MO means molecular orbitals formation. Number of molecular orbitals formation. Second one, it should follow symmetry. It should follow symmetry. Okay. What is the symmetry? For example, P sub shell having 3 orbitals, Px, Py, Pz. Next, Pz, Py, Px. Whenever P orbitals undergoing to overlap, Pz only overlap with Pz, Py only overlap with Py, Px only overlap with Px, Pz never overlap with Px, Px never overlap with Px. So that's why it should follow symmetry nature. Okay, these are the conditions for MOT. Next one, LCAO theory, linear combination of atomic orbital theory, LCAO theory. Right. According to this theory, whenever atomic orbitals combine to formation molecular orbital, half of the molecular orbital has lower energy and half of the molecular orbital has higher energy. Understand? Whenever atomic orbitals combine to form molecular orbital, half of the molecular orbital has lower energy and half of the molecular orbital has higher energy. That's why atomic orbitals undergoing to combine to formation of molecular orbital, MO means molecular orbital. This molecular orbital has two types. Half of the molecular orbital has lower energy. This lower energy molecular orbitals is called BMO, bonding molecular orbital. Bonding molecular orbitals. Bonding molecular orbitals. Then half of the part is higher energy. Higher energy. This higher energy molecular orbitals are called ABMO, anti-bonding molecular orbital. Bonding molecular orbital, anti-bonding molecular orbitals. So then this theory explains in the form of amplitudes, wave function and amplitudes. Bonding molecular orbitals when formed and anti-bonding molecular orbitals when formed. Okay. When the addition, that means wave function of psi A plus psi B, psi A plus psi B. That means when the two atomic orbitals A and B undergoing to overlapping. Okay, for example, A and B two atomic orbitals overlapping, psi A plus psi B addition means bonding molecular orbital formation. Next, subtraction means psi A minus psi B anti-bonding molecular orbitals formation. Okay, so remember, according to this theory, addition takes place means psi A plus psi B bonding molecular orbital formation. Subtraction takes place means psi A minus psi B anti-bonding molecular orbital formation. This theory explains in the form of wave functions. Okay, first suppose when the two A and B two atomic orbitals undergoing to overlapping formation of AB molecular orbital. This AB molecular orbital has two types: BMO bonding molecular orbital, ABMO anti-bonding molecular orbital. It has lower energy, it has higher energy. So bonding molecular orbital, how does formation? Addition, psi A plus psi B. Anti-bonding molecular orbital, how does formation? Subtraction, psi A minus psi B. Okay, so this theory explains addition means bonding molecular orbital formation, subtraction means anti-bonding molecular orbitals formation. Okay, next, same theory explains in the form of amplitudes. BMO means constructive method. Okay, this is constructive in bracket psi A plus psi B. Next, ABMO anti-bonding molecular orbital. Right, this is destructive. Subtracted here, psi A minus psi B, here A greater than B. Next, same anti-bonding molecular orbital, totally subtractive. This is also destructive. This is totally subtracted. So psi A minus psi B, right here A equal to B. So bonding molecular orbital means constructive method, anti-bonding molecular orbitals means destructive method. So constructive, destructive. Okay, this is about bonding molecular orbitals and anti-bonding molecular orbitals. Then, how does their formation? Okay, for s orbital, for s subshell, for example, 1s, this is the electron, plus another 1s, two atomic orbitals undergoing overlapping, formation of right. This is the bonding molecular orbital. This is also bonding molecular orbitals represents by sigma. Next one. Nodal plane, this one, nodal plane. Right. This is nodal plane. Nodal plane. This is sigma star 1s. That means anti-bonding molecular orbital. So this is lower energy bonding molecular orbital sigma 1s. So for S subshell, bonding molecular orbital represents by sigma, anti-bonding molecular orbital represents by sigma star. So anti-bonding molecular orbital having one nodal plane. NEET exam asking amma. NEET exam, you should remember in F subshell, anti-bonding molecular orbital only having nodal plane. Bonding molecular orbital does not have nodal plane. Okay, this is the for S subshell. Okay, then for P subshell important. For P subshell, okay, listen. P subshell having three orbitals, Px, Py, Pz. Okay, another orbital, suppose Pz, Py, Px. Here Pz to Pz, end to end overlapping formation. End to end overlapping. That's why Pz plus Pz atomic orbital formation. Two types of molecular orbitals. Lower molecular orbitals called sigma Pz. Higher energy molecular orbitals, anti-bonding molecular orbitals are called sigma star Pz. So sigma Pz means bonding molecular orbital. Sigma star Pz means anti-bonding molecular orbitals. Pz to Pz, end-to-end overlapping happen. Next, Py to Py, Px to Px, sideway overlapping. Sideway overlapping. That's why Px to Px formation, bonding molecular orbital is pi Px, pi bond. Pz to Pz, end overlapping. That's why sigma bond formation. Py to Py, sideway overlapping. That's why pi bond formation. Px to Px, sideway overlapping. That's why pi bond formation. That's why pi Px is the BMO. Next, pi star Px is the anti-bonding molecular orbital. Same like that. Py also same. Py to Py. Lower energy BMO is called pi Py. Next, anti-bond molecular orbital ABMO is called pi star Py. Okay, that's why this is about the P subshell. So Pz to Pz, end overlapping. Okay, bonding molecular orbital sigma Pz, anti-bonding molecular orbital sigma star Pz. Okay, next Py to Py, Px to Px, sideway overlapping. That's why bonding molecular orbital is pi Px or pi Py, anti-bonding molecular orbitals are pi star Px or pi star Py. Okay, then orbitals, how does overlapping in P subshell? First one, Pz in Pz. Minus plus signs are important of exam. Plus minus plus plus minus. undergoing to overlapping. This is the bonding molecular orbital of Pz. Bonding molecular orbital of Pz. Okay, minus plus low. Reverse, plus low, minus low. Okay, minus plus, plus minus. This like that overlapping. And this is one atomic orbital. This is second atomic orbital. One atomic orbital overlap by another atomic orbital, like that. Like that overlapping. Here formation bonding molecular orbitals. Understand now? Next, minus plus, then minus plus, right. So these two atomic orbitals also Pz only. This is all Pz. This is Pz. Next Pz, Pz. Okay, Pz to Pz. Here minus electron nodal plane. 5 star P antibody molecular orbital compulsory nodal planes formation. Nodal planes formation. Right. This is the nodal plane. Nodal plane. This is anti-bonding molecular orbital. Anti-bonding molecular orbital. This is sigma Pz. This is sigma star Pz. Sigma Pz, sigma star Pz. Okay, diagrams in exam sometimes directly asking about. Here opposite lobes, opposite side slopes. Here same side slopes undergoing to overlapping. This is bonding molecular orbital. This is anti-bonding molecular orbital. Here nodal plane is formation. Here, so anti-bonding orbital, nodal plane is formation. Understand? Next one, writing about px orbitals. Px or py? Px or py? Px or py? Plus or minus. Okay, whether px or py? Plus or minus. Plus minus, plus minus. Okay, here overlapping, both are overlapping. Right. This is nodal plane. This is whether bonding molecular orbital, whether pi px or pi py. Bonding molecular orbital. This is nodal plane. Sorry, nodal plane. Nodal plane. Okay. So in px and py, bonding molecular orbital also having nodal plane amma. In PZ, bonding molecular orbital does not having nodal plane. In PZ, bonding molecular orbital does not having nodal plane. But PX and PY, bonding molecular orbital also having nodal plane. Okay. Next one, anti-bonding orbitals. Here on the right. Plus, minus. Minus, plus. Minus, plus. Okay, both are undergoing to overlapping. Plus, minus. This is nodal plane. Minus, plus. Okay. This is nodal plane. This is nodal plane. So this is the PX and PY anti-bonding molecular orbital. Pi star PX. Pi star PX means PX anti-bonding molecular orbital, or pi star PY. So anti-bonding molecular orbital. Anti-bonding molecular orbitals. Okay, these are the diagrams. So in exam, orbitals representation direct question asking amma. That's why 2-3 times practice with signs. Signs important. With signs, positive negative signs important. With lobe signs, 1 or 2 times you have to practice. You can easily understand. Okay, this is about the orbitals schematic representation. Next, we have to discuss about bond order. Bond order. Generally, what is bond order? Number of bonds between two atoms. Already we know. So, if MOT bond order equal to half of bonding molecular orbital to anti-bonding molecular orbitals. Bond order equal to 1/2 number of bonding molecular orbitals subtraction, number of anti-bonding molecular orbitals subtraction. That's why number of bonding molecular orbitals minus number of anti-bonding molecular orbitals. Okay, number of anti-bonding molecular orbitals. Here we counting electrons amount. So number of bonding molecular orbitals having electrons minus number of anti-bonding molecular orbitals having electrons representation. So half into number of bonding molecular orbitals having electrons minus number of anti-bonding molecular orbitals having electrons. This is the bond order. BO means bond order. Now here if bond order equal to negative answer come means, if bond order equal to negative values come means, negative integers, negative values come means that molecule has unstable, unexist. Okay, next, if bond order equal to 0 means, bond order equal to 0 value come means, that also unstable, unexist. Unstable and unexist. Next, if bond order equal to positive values come means, more stability. Less bond order means less stability. Next one, bond order directly proportional to bond energy. Bond energy inversely proportional to bond length. Inversely proportional to bond length. So bond order directly proportional to bond energy, inversely proportional to bond length. Okay, so these concepts you should remember. Now we have to find out bond order of some molecules. First we have to discuss about some examples. Hydrogen molecule formation. Hydrogen molecule, how does formation? Hydrogen plus hydrogen. 1s1 plus 1s1. Here formation, two types of molecular orbitals. Sigma 1s, sigma star 1s. Lidharama, in MOT we should follow Hund's rule, above principle and Pauli's rule. Here also, like electronic configuration, here also we should follow above Hund's and Pauli's principles. That's why one orbital, for example sigma 1s, bonding molecular orbital, sigma star 1s, anti-bonding molecular orbital. One orbital capacity 2 electrons. Okay, bonding molecular orbital capacity, maximum capacity 2 electrons. Anti-bonding molecular orbitals also capacity 2 electrons. Okay, now that's why sigma 1s is lower energy, sigma star 1s is higher energy. Here 1 plus 1, how many electrons here? Here 1 plus 1 equal to 2 electrons is there. First of all, now here we have to follow above principle. What is above principle? Electron first enter into lower energy, then enter into higher energy. That's why always in this MOT, electrons first enter into bonding molecular orbitals, then enter into anti-bonding molecular orbitals. Understand now? Here also we should follow above principle. According to above principle, electrons first enter into lower energy orbitals, then enter into higher energy orbitals. Here which is lower energy orbitals? Bonding molecular orbitals. Here which is higher energy orbitals? Anti-bonding molecular orbitals are the higher energy molecular orbitals. That's why the electrons first enter into bonding molecular orbitals, then enter into anti-bonding molecular orbitals. Okay, here 1 plus 1 2 electrons. What I say, one orbital capacity 2 electrons. That's why these 2 electrons filled here only. These 2 electrons here empty, because the 2 electrons completed, no third electron. That's why anti-bonding orbital is the empty. Okay, that's why hydrogen configuration, hydrogen configuration sigma 1s, hydrogen configuration sigma 1s. That's all. Sigma 1s, sigma star 1s, 0 electrons. They given sigma 1s, sigma star 1s also, but sigma star 1s 0 electrons. That means here 2 electrons filling, here 0 electrons. Next, bond order equal to half of the number of NB means number of bonding orbitals electrons. Number of bonding orbital electrons minus Na. Na means number of anti-bonding electrons. Np means number of bonding molecular orbital electrons. Na means number of anti-bonding molecular orbital electrons. Now bond order equal to 1 by 2. Okay. Bonding molecular orbital how much? 2. 2 minus anti-bonding molecular orbital 0, empty, equal 1 by 2 into 2, 1. 1 means positive integer. 1 means positive integer. That's why hydrogen molecule stable exist. Stable exist. This is about the hydrogen molecule. Next one, helium. Next one, helium. Helium. He2 molecule. Helium. He2 molecule. Okay. Helium molecule, how does formation? Helium plus helium. 1s2 plus 1s2. 2 plus 2, 4 electrons is there. Here, 2 types of molecular orbital. Sigma 1s, sigma star 1s. Okay now. Here 4 electrons is there now. That's why 2 electrons enter into sigma 1s. Remaining 2 electrons enter into sigma star 1s. 2 electrons enter into bonding orbital. 2 electrons enter into anti-bonding molecular orbital. Now bond order equal to 1 by 2. Number of bonding electrons 2 here. 2 minus number of anti-bonding electrons 2. So half into 0, 0. That's why helium unstable, not exist. What I say? 0 negative values come means unstable, does not exist. Positive integers only stable and exist. Okay, this is about helium molecule. So use this formula. Bond order equal to 1 by 2 into number of bonding molecular orbital electrons minus number of anti-bonding molecular orbitals. So lithium, beryllium, boron, carbon, nitrogen, like that only doing. Sir, okay. For example, nitrogen. Okay. Nitrogen configuration. Nitrogen molecule formed by nitrogen plus nitrogen. 1s2, 2s2, 2p3 now. 2p3 means 2px1, 2py1, 2pz1. 1 nitrogen. So another nitrogen also having now. Same. 1s2, 2s2, 2px1, 2py1, 2pz1. 2 nitrogens configuration. Now here formation. Okay. First configuration important. 2 types of orbitals formation. Bonding molecular orbitals, anti-bonding molecular orbital formation. First is that 1s2, 1s2, 2 plus 2, 4 electrons. That's why 2 electrons enter into s bonding molecule. Listen, same energy orbitals only undergoing to overlapping. 1s only overlapping. 2s only overlapping. 3s only. Understand? 1s never overlap with 2s. Same energy orbitals only overlapping. Same energy orbitals. That's why here 1s only. So 1s2, 1s2. Sigma 1s, sigma star 1s. Okay, 2 plus 2, 4 electrons. 2 electrons enter into bonding, sigma 1s. 2 electrons enter into sigma star 1s. Next, 2s2 to 2s2. 2s2 to 2s2. following. So electrons first fill into lower energy orbitals now. Bonding molecular orbital is lower energy. Anti-bonding molecular orbital has higher energy. That's why two. But again Pauli's rule. One orbital maximum electrons, 2 electrons. That's why these 2 electrons enter into bonding molecular orbital only. Sigma star p is at empty. Sigma star p is at empty. Then nitrogen, how many bonding molecular orbital? Sigma 1s, sigma 2s, pi 2px, pi 2py, sigma 2pz. Antibonding molecular orbital for nitrogen, sigma star 1s, sigma star 2s, pi star px, pi star py, sigma star pz. Here sigma 1s how many electrons? 2 electrons. Sigma 2s 2 electrons. Pi 2px 2 electrons. Pi 2py 2 electrons. Sigma 2pz 2 electrons. Sigma star 1s 2 electrons. Sigma star 2s 2 electrons. Here in nitrogen anti-bonding molecular orbitals does not fill in. So in nitrogen anti-bonding molecular orbitals does not fill in. That's why a 0 electrons fill in. Now bond order equal to 1 by 2 number of bonding electrons. Counting 2, 4, 6, 8, 10. Okay, now 4, 6, 8, 10. 10 minus anti-bonding electrons. 2 plus 2, 4. 2 plus 2, 4. That means equal to 3. So bond order of nitrogen is 3. So like that you have to calculate. Shortcut method is there, amma. Shortcut method is there, but concept also should know it, because in exam diagram methods also giving, configuration also they asking. In exam they ask configuration and schematic diagrams also. That's the concept you should know. Then next I will explain the shortcut also. Okay. Finally, here what rule is there, amma? See, up to nitrogen, hydrogen H2 to nitrogen, hydrogen to nitrogen, configuration order, amma. Configuration order, sigma 1s come, next sigma star 1s come, sigma 2s come, sigma star 2s come, next pi 2px equal to pi 2py come, pi 2px equal to 2px 2py having same energy, x equal to y, x orbital y orbital having same energy. Okay, next sigma 2pz come, next pi star 2px equal to pi star 2py come, finally sigma star 2pz come. Okay, this is hydrogen molecule to nitrogen molecule. Configuration order, configuration order should remember. Okay, up to here common. So here somewhat confusion. Okay, next from O2, from oxygen molecule, from oxygen molecule, from oxygen molecule, right? Configuration order, that means from atomic number 8. A&O means atomic number. From A&O means atomic number 8. Atomic number 8. Configuration order, sigma 1s common, sigma star 1s, sigma 2s, sigma star 2s, up to that common. Now here sigma 2pz come front. That means sigma 2pz comma. Now pi 2px equal to pi 2py. Then pi star 2px equal to pi star 2py. Finally sigma star, yes, here only. Finally sigma star 2pz. Sigma star 2pz. This is configuration order from atomic number 8 or from mole to molecule up to from hydrogen to nitrogen, including nitrogen. This is configuration order, energy order. This is also called energy order. Right here, energy order. Energy order. Energy order. Okay, so from hydrogen to nitrogen, after sigma star 2s, pi 2px, pi 2py come over. After that sigma 2pz come. The remaining same. From oxygen or atomic number 8, after sigma star 2s, after sigma star 2s, sigma 2pz come. Up to nitrogen, pi 2px come. Pi 2px equal to pi 2py come. But from oxygen, sigma star 2s after, sigma 2pz come. After that, pi 2px equal to pi 2py come. This is the energy order, energy diagram. This order you should remember. Okay? Up to nitrogen, sigma star 2s after, pi 2px, pi 2py come. Then sigma 2pz come. From oxygen molecule or from atomic number 8, after sigma star 2x, sigma 2pz come. Then pi 2px, pi 2py come. Okay, here important. Like that means you feel antibody. Okay, you feel antibody. Okay, here this one. Okay, this is about the nitrogen molecule and energy orders. Up to nitrogen, one type of energy order. From oxygen, oxygen fluorine, then different compounds, one energy order. Okay, students. Thank you. Thank you.